lesson is about absolute value equations, and before we go over our 5 examples, I want to go over today's 2 vocabulary terms. The first is absolute value equation. An absolute value equation is an equation that contains an absolute value expression. And just to remind you, an absolute value expression has those 2 straight brackets with a term or a number inside, sometimes an expression. And this one is a little tricky. This is brand new to you. Absolute deviation. An absolute deviation of a number x from a given value is the absolute value of the difference of x and a given number. And here we have a formula, so to speak, that we follow. Our absolute deviation, as the definition says, equals the absolute value of x and a given number. And as we work through these problems, I know that these terms will be clear to you. And one term that I refrain from putting on your vocabulary list is absolute deviation. I thought it's probably familiar enough, but just to remind you, when we talk about absolute value, we talk about the number of steps, for lack of a better way to say it, is a number is from 0. So in other words, the absolute value of a positive 5 is 5, because positive 5 is 5 steps on a number line from 0, and the absolute value of a negative 2 is a 2. So when we talk about absolute value, we're always talking about the positive of a number. Let's take a look at our example. The absolute value of a plus 6 equals 2. Now, you may or may not remember that when we talk about a term that has a variable in an absolute value expression, it has 2 possible values. So in other words, if the absolute value of x equaled 8, then that means that that 8 could either be equal to a positive 8, which is 8 steps away from 0 on a number line, or that it could have a value of a negative 8, because a negative 8 is also 8 steps away. And that's how we're going to look at this. Whenever we see an equation that has an absolute value expression in it, what we have to do is set this up into 2 separate equations. In both of these equations, we are going to lose the absolute value brackets. Whatever is inside the brackets, we are going to copy here, and we're going to have it equal to 2, because that's what it says. But in our second equation, our first piece stays exactly the same, but we have to make our equation equal to the opposite of the answer that they give us. So for this problem, as you can see, the absolute value of a plus 6 equals 2. In order to solve it, we break it into 2 separate equations. A plus 6 equals 2, and a plus 6 equals negative 2. And then we go and we solve this the same way that we've been doing since pre-algebra. We want to isolate the a, so if this is just one step, we put a positive 6 on both sides. And so one of the values of a is negative 4. And we'll do the same thing here, put a negative 6 on both sides. And here we get that a equals negative 8. So these are the 2 values of a in this expression. And if you wanted to check your answer, you could. When a is a negative 4, and a positive 6 give us a positive 2, which has an absolute value of 2. And then when a is equal to negative 8, a negative 8 and a positive 6 make a negative 2, and the absolute value of negative 2 is 2. Let's try another one. Now, the reason I wrote these directions exactly this way is that this is the way you'll see them when you are working in your textbook and when you're working in your workbook. And so I wanted you to know exactly where to reference if you were having trouble solving this. Find the values of x that satisfy the definition of absolute deviation for the given value and a given absolute deviation. So here our given value is 6, and our absolute deviation is 15. And just to remind you what the formula is, our absolute deviation is equal to the absolute value of x minus the number that we're given, the given number. And the way that we're going to set that up is the absolute deviation, which here is 15, is equal to the absolute value of x. So you see, this x is always going to be there, minus the number that the given value, which is 6. So 15 equals the absolute value of x minus 6, and we're going to solve this in exactly the same way we solve the absolute value equation in example 1. Here, this will be 15 is equal to x minus 6. And our second equation is going to be a negative 15 is equal to x minus 6. Then you'll solve by putting a positive 6 on both sides. And here, one of the values of x is a positive 21. And the second value of x for this equation is a negative 9. So just to remind you, as you can see, the computation itself is very basic, it's very easy. This is more about learning the terminology and learning how to solve these equations. Let's look at our third example. The absolute value of 2c plus 5 is equal to 21. So by now you probably already got started solving out this problem, or at least you already know how you have to do it. Because we have the absolute value brackets here, you know you're going to break this. You're going to, not break it up, but derive two different equations from it. 2c plus 5 equals 21, because we have our 2c plus 5 equals 21. So the only difference between our first equation and our original is the lack of absolute value brackets. And then our second will be 2c plus 5 equals negative 21. And what we have here is just a two-step equation. Again, this is the kind of math that you've been doing since pre-algebra. So I'm going to refrain from taking the time to solving these, but I want you to solve these on your own. Okay, this is a little different. Notice we have extra pieces here. In example 4, we have 4 times the absolute value of x plus 9 minus 5 equals 19. So in the way that when we solve equations, we want to get the variable by itself, our first goal, since we have these extra pieces here, is to get the absolute value expression by itself. And we are going to look at this in the same way that we have been with equations. When you look, you can see that the expression, the absolute value, x plus 9, is being multiplied by the coefficient 4, and it also has a negative 5 with it. So, as you can guess, we are going to start by negating that constant. What that means is we have 4 times the absolute value of x plus 9 minus 5, and then we're going to put a positive 5 with it. And because it's an equation, we have to change both sides equally. So here I am putting my positive 5 with a positive 19. These cancel each other out, and we're left with 4 times the absolute value of x plus 9 equals 24. Now we have to get rid of this coefficient. So we're going to divide both sides by 4, and we're left with the absolute value of x plus 9 equaling 6. Now that we have our absolute value expression by itself, meaning without its coefficient and without its constant, we can go on ahead and make this into its 2 separate equations the way that we've been doing, and solve for x. Solve for the 2 values of x. First, it will be x plus 9 equals positive 6, and secondly, x plus 9 equals negative 6. And again, I want you to jot down, figure out those answers on your own. Now we have one last example. And this is very similar to the one that we just solved because there is a coefficient and there is a constant, but you must know that there's a twist, otherwise why would we spend the time doing two examples that were the same? But we're going to go on ahead and solve it in the same way. First, by putting a negative 11 on both sides so that we can start whittling away at these extra pieces that we don't need. So we'll put a negative 11 on both sides. That gives us 2 times the absolute value of 5x plus 1 equaling negative 10. Then we're going to divide both sides by positive 2. And we end up with the absolute value of 5x plus 1 equals negative 5. And this is very important. This is the twist. We have our absolute value expression by itself, but you notice it's equal to a negative number. If you recall, what I said earlier was the absolute value of a number is always going to be in the positive because we are not talking about the sign that it's attributed to it. We're talking about the number of space it is on a number line to 0. Since we have an absolute value here equal to a negative number, it means that this equation has no solution.